Alright, so continue. Number 4, find the arc length of the indicated portion of the curve. So the arc length formula is going to be integral from a to b. Actually, it's the speed, right? And then dt. So v, the velocity, is negative 6I plus 9j plus 2k. And hence the speed, which is the magnitude, plus 4, right? So it's gonna be square root of 121, which is 11. Okay, so from 2 to 7, so it's gonna become 7 to 11 times 5. Which is 55. Okay, which is 50. That's number 4. Number 5. So, given this position, find the unit tangent vector. So, the unit tangent vector is the velocity over its magnitude. So we find the velocity first. 77t to the power 6, right? Plus 14t to the power 6. And then plus 70 t to the power of 6. Okay, of 6. And so the magnitude is going to be 14 to the power 6 squared, and then plus 70 squared. So it's easy to see that we can bring those t to the power 6 in the front. And it turns out this number 77 squared plus 14 squared and then plus 70 squared, it equals, so this is going to become into 59229 plus 14 times 14 is 196 and plus 4900. Turns out this becomes into square root of 11025. Okay, square root of 11025. And turns out, and that gonna give us $105. Okay, so which is 105t to the power 6. So once you drive that, so the unit tangent, it becomes into 77 t to the power 6 j k plus 14 k, and that will be 11 over 15 I 2 over 15 j and plus 2/3 k here. Okay, that's how to try that. That's number 5. Number 6, it asks us to find the principal unit normal vector. So noticing that n is dt over its magnitude. Okay. So to drive principal unit normal vector, we first need to find what is the unit tangent vector. That will give us 2 sine t, right? Plus 2 t cosine t and minus 2 sine of t I plus the derivative of this is 2 cosine t, right? Plus 2t negative sine of t, and then minus 2 cosine of t. Oh, actually this part is going to be k. Turns out, so we have, it's a 2t cosine t I minus 2t sine t k. So that's the velocity and its magnitude. You will see that if we put one more condition, that is, okay, maybe say our t is greater than 0, and you can take a look. So its velocity is going to become into 2t cosine t squared. Turns out it's 2t. So the unit tangent is just cosine t I minus sine t k, and then dt becomes into negative sine of t I minus cosine t k. Okay, minus cosine t k. And turns out the magnitude is equals 1. So the unit, principal unit normal vector, which is just a dt, it's negative sine ti minus cosine t. Okay. Okay. That's number 6. Number 7. Find the curvature about the this curve here. So first of all, we'll define the curvature. It is the magnitude of dt ds, and we can do a little bit chain rule, so that will give us dt dt times dt ds. dt ds, since ds dt equals the magnitude, so dt ds equals to 1 of the magnitude. To simplify, so the curvature expression, so that's what we're going to use. So find its the velocity, give us as a negative 24 sine of 8t I, right? And minus 24 cosine of 8tj, and then plus 0. Okay. So the magnitude, as you can see here, it will equals 24. Okay. So the unit 10, so it's negative sine 8t I minus cosine of 8tj, and so the dt it's going to give us is negative 8 cosine of 8t I. This comes in plus 8 sine of 8tj. So the magnitude for this piece is going to be 8, right? So the curvature, it's 1 over 24 times 8, which is 1 over 3. Okay, so that's the end of those problem solution. Thank you.